Here we have a system of equations based on a word problem. So the word problem is a special promotion is offered through catalog where we can buy special running socks for $4 a pair. So it looks like here that my change in Y or my change in X or my slope is dollars to pairs of socks. So it looks like that's what I'm comparing. So we need to pay a shipping charge of $10. So that's my cost. We can buy the same socks from a store for $5.15 a pair. So how many would we need to buy to make it worthwhile? So first of all, we need to let X equal. Okay, so in this case, the quantities we're relating are dollars to pairs of socks. So the dollars are dependent on the pairs of socks. So the X's are independent, which is our number of pairs of socks. And that makes Y the dependent, which is the total cost. Okay, so that's the first thing. We need to understand what we're relating, and then we need to come up with our equations. So our first equation is going to be based on the $4 a pair, which is a cheaper amount, but we have to pay a shipping charge. And we're going to show it this way: $4 a pair of socks plus the initial shipping charge of $10. And so we're going to graph this. So we're going to end up with 4x plus 10. For the other relationship, we'll call y2. It's strictly based on $5.15 times the number of pairs of socks. And so I'm going to graph this. So I'm just going to make my graph, scale my graph a little bit, because I don't need to have negative socks or negative dollars. And I can see that, I don't know what would be reasonable. Let's say I'm going to buy, 10 socks. Okay, so I'm going to get up to maybe, looks like $100 or so, something like that. So that's just a general scale here. So I'm just going to go from negative 1 to 10, and maybe negative $10 to $100. That's kind of a general scale for this graph. So I'm going to graph my first relationship. It's going to have a slope of 4 and y-intercept of 10. So it's going to start here, and it's going to go up by 4s. So when x is 10, y is going to be 50. So it's going to be right about here. Okay, so I just did a quick table of values here. 0, 10, 10 socks, and $50. Okay, and then for the other x and y, 0, 0, and we'll do 10 socks as well. It's going to be $51.50. Okay, this one's going to go up, and it's just going to be a little bit more expensive there. And we want to figure out when these graphs are going to be the same, or if I buy more socks than where they intersect, I want to buy the cheaper rate, which is $5.15 a pair. $4 a pair. So the blue line, and if I buy less than that many socks, I want to use $5.15 a pair. So I need to solve for that intersection. I'm going to find out where these intersect by graphing these. So I'm going to go to my graphing tool. Okay, my graphing tool, I'm going to plug in 4x plus 10 and 5.15x. Okay, and I need to scale my graph a little bit, but my graph is going to intersect. Where they intersect is going to be at 8.696, and y equals $44.73, or 78 cents. So this is not really a nice intersection point, but I do know that I can't have part of a sock. So if I buy 9 socks, I'm going to use a $5.15. I'm going to use a $4 a pair. If If I buy less than 9, or if I buy 8 socks, I want to use a red graph, which is going to be cheaper, or the $5.15 pair. So how many would we need to buy to make this worthwhile, to buy $5.15? We need to, so X needs to be less than 9 pairs of socks if we want the red graph to be more worthwhile. Okay, that would make us choose that.